2016 paper 1, sequences and series, question 5. The first 5 numbers in a pattern of numbers are given in the table. Follow the pattern in the table above to write the next 3 numbers into the table. So I can see from 3 to 15 is plus 2, then from 15 to 19 is plus 4, 19 to 25 is plus 6. So you can see they're going up 2 in every time. Therefore, here I have to add 10, here I have to add 12, and here I have to add 14. So we get 43, 55, and 69. So part 2, use the data in the table to show that the pattern is quadratic. Whenever they ask you that, all you have to do is show that the second difference is the same. So I'm literally taking this table with those differences, which are not common, they're different, and I'm bringing them down here. So 13, 15, 19, 25, 33. I do my first difference, plus 2, plus 4, plus 6, plus 8. They are not common. But when I look at the second difference, it's plus 2, so they are common. So the second difference is the same, therefore it is a quadratic. Part B. The u of n is equal to n squared plus bn plus c, where b and c are elements of the integers. Z are integers. Find the value of b and the value of c. So we've done a couple of these already. So use the answers in the table, this table here, to make 2 equations, and then we're going to use simultaneous equations to solve. So I know that this is my formula. The u of n is equal to n squared plus bn plus c. This is u1, my first term, okay, and I know the answer is 13. So I know the first term is 13. So the u of 1, using this formula here, sub in 1 for n here, and we get the u of 1 is equal to 1 squared plus b times 1 plus c, and we know the answer is 13. Multiply out. 1 squared is 1, b by 1 is b, plus c is equal to 13. Bring your 1 over to the right-hand side. 13 minus 1 is 12, and we got b plus c is equal to 12. Then go to the second term. The u of 2 is equal to 15. So we know this. The u of 2 is equal to 15. So the u of 2 is equal to, using our formula, sub in 2 for n, 2 squared plus sub in 2 here beside b times 2 plus c is equal to 15. 2 2's are 4, plus 2b plus c is equal to 15. 2b plus c is equal to 15, bringing over our 4, minus 4, so we now 2b plus c is equal to 11. So now we've got 2 equations. We've got the first one and the second one. We put them together, and we now have simultaneous equations, and we're going to solve them. So I just feel it's easier to make b positive, so I'm going to multiply the top line by minus 1. Okay, so we now have minus b minus c minus 12 on the top line. Our bottom line is 2b plus c is equal to 11. Minus c plus c is 0. 2b minus b is 1b, and minus 12 plus 11 is minus 1. So we know b is equal to minus 1. To find what c is, I'm going to sub back into the top equation. B plus c is equal to 12. So b is minus 1, sub in, minus 1 plus c is equal to 12. Bring my 1 over, c is equal to 12 plus 1, c is equal to 13. Moving on to part C. The table below shows the first 5 terms of an arithmetic sequence. Find an expression for Tn, the nth term of the sequence, hence or otherwise find the value of T30, the 30th term. So this is a different set of numbers. We've got T1 all the way down to T5. I know A is equal to 12, and I work out my common difference here, and I see it is 2. So we have to find Tn. A is 12, D is 2. We need our formula. Go to the formula tables. We find the T of n, and it tells you it's the T of n. T of n is equal to A plus n minus 1 times D. I'm going to put my D here. A is 12, sub in. D is 2, sub in. So 12 plus, multiply out the brackets, 2n minus 2. Bring the minus 2 and the 12 together, 2n plus 10. Then they ask you for the T of 30. So all we have to do is sub in 30 to our answer here. So Tn is equal to 2n plus 10. I always write the formula to make sure I don't make any mistakes. T of 30 is equal to 2 times 30 plus 10. T of 30 is equal to 60 plus 10. T of 30 is equal to 70.